Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we will be continuing with Mathematics class 12th. The chapter that we are dealing with is integrals, and in integrals now is the turn of exercise 7.10. So this particular exercise is based on definite integration and the idea of substitution. How can we apply substitution over definite integration? That is what this exercise is based upon. So let's begin with the first question and see what does the question say. Along with the question, we'll see the idea of substitution and how do we apply that over here. The first question says, evaluate the integrals in exercises using substitution. Okay, so integral from 0 to 1 x upon x square plus 1. How can we apply substitution on this? I is equal to integral from 0 to 1 x upon x square plus 1 dx. This is the thing. Now, what's the substitution that you want to apply? If you observe this x square plus 1 and its derivative is present at the top. Oh, the derivative is 2x. Yes, the derivative is 2x, but we can always multiply and divide by 2. The constants do not create so much problem for us. So, we'll use the substitution x square plus 1 is equal to t. And this tells me 2x dx will be equal to dt. That's the first thing that this tells me. What about the lower limit? Lower limit has x equal to 0. This tells me, okay, if x is equal to 0, then t will be equal to 1. This is what this tells me. Lower limit of integral. The upper limit of integral is x equal to 1. And putting x equal to 1 will give me t equals 1 square plus 1, which implies t equals 2. That's the idea of substitution for definite integral. Once you do this much, therefore I can be further written as integral from lower limit 1 to 2 for the values of t. X dx will be dt upon 2. So this is 1 by 2 dt upon x square plus 1, which is t. This is what you get. And this becomes 1 by 2 log mod t. And now I'll directly substitute the values of t, the new limits, from the new limits from 1 to 2. What do I get? 1 by 2 is okay. This is log 2 minus log 1 in this bracket over here. Yes, 1 by 2 is outside. This becomes 1 by 2 log 2. That's all, because log 1 is simply 0, and this is my required answer for this first question, as you can see over here. In the second question, we have integral from 0 to pi by 2 under root of sine phi into cos power 5 phi. How do we attempt this question? So, once again, we'll see some substitution over here somehow. So, I is equal to integral from 0 to pi by 2 under root of sine phi into cos power 5 phi d phi. This is the question. And if you observe carefully, this sine phi in the under root is creating a lot of problems. So yes, we'll have to substitute sine phi as a new variable t. And if you observe carefully, the derivative of sine phi is present with d phi. Yes. So let sine phi is equal to new variable t. That tells me derivative of this, which is cos phi d phi, will be equal to dt. What about the limits? The lower limit, for the lower limit, the value of phi, this is with respect to phi, right? So the value of phi is 0. And this tells me the value of t will be sine 0, which is 0 again. Upper limit tells me phi is equal to pi by 2, which further tells me t will be sine phi, which is sine pi by 2, that is 1. So you have found the lower limits and the upper limits. You've also used substitution for definite integral, as you can see over here. Therefore, I becomes equal to what? This becomes equal to, from the lower limit 0 to 1, I have under root of sine phi first of all. Under root of sine phi will be under root of t times. You see that you have cos power 5 phi, 1 cos phi d phi will become dt. And remaining will be cos power 4 phi, which is square of cos square. Okay. So cos square is important, and cos square is nothing but 1 minus sin square. Yes. So cos square is cos power 4, and we can replace cos square phi by 1 minus sin square phi, which is 1 minus t square. This is what I can replace this with. Yes. Once I do this, then do you see that after this expansion, the question will become pretty simple. So this expansion will tell me 1 minus 2 t square plus t power 4 dt is what I have over here. This becomes integral from 0 to 1 t power 1 by 2, multiplying this with this, minus 2 times t power 2, t power 1 by 2 is t power 5 by 2, plus t power 4 1 by 2 will be t power 4 plus 1 by 2 will be 9 by 2 dt. This is what you'll have. Yes, and this integral can now easily be found. This is t power 3 by 2 upon 3 by 2 minus 2 times t power 5 by 2 plus 1, which is 7 by 2 upon 7 by 2 plus t power 9 by 2. Okay, 9 by 2 plus 1 will be 11 by 2 actually. This will become 11 by 2 upon 11 by 2. And the limits of this will be 0 to 1. This is what you'll get. Okay, after this, the next step can be written over here, which gives me I is equal to what? You substitute 1, 1, 1, then you substitute 0, 0, 0, everything becomes 0. So you substitute 1 over here, 1 power 3 by 2 is 1, this becomes 2 by 3, minus 2 times, this becomes 1 power 7 by 2, which is 1, this becomes 2 by 7, plus this is 1 power 11 by 2, which is 1, this becomes 2 by 11. Now you can simplify and get the final answer. Rest all terms will be 0, we don't need to worry about them. 7, 3 and 11, the LCM, what will be the LCM? So this is 7 times 3 is 21 and 21 times 11 is 231. That will be the LCM for this. This numerator will be 77 times 2, okay, which is 154. Minus 4 times 33 is what I'll get. 4 times 33, let's write that properly. 4 times 33. Now that is 132. Is it? Yes. 132 plus 7 times 3 is 21 times 2 is 42. This is what you have, right? Let's check the calculations. 7 times 3, okay, we have already done that, 21 times 11. Let's multiply 11 times 3 is 33 and times 7. So this will be 7 times 3 is 21 and 2, 23. 231 is okay. And 11 times 7 is 77 times 2. So this 70 is 140 and 154 is okay. 11 times 3 is 33, times 2 is 66, times 2 is 132. And 7 times 3 is 21, times 2 is 42. Okay, this looks correct. 154 minus 132. What is that equal to? This is 22. If you see this carefully, yes, this is 22 plus 42. 42 and 22 will be 64 upon 231, and that is my final answer for this particular question over here. In the third question, we have integral from 0 to 1 sine inverse 2x upon 1 plus x square, and we need to use substitution on this. How do we use that? I is equal to integral from 0 to 1 sine inverse 2x over 1 plus x square dx. This is what you have. And what's the substitution that we want to use over here? This x, if you recall the formula for sine 2 theta, this x can be replaced with tan theta. Once I replace this x with tan theta, what do I get? So 2 tan theta 1 plus tan square theta will become sine 2 theta. Sine inverse sine 2 theta will be simplified to 2 theta first of all. And this dx will also simplify to something. So how do we do that? We replace x by tan theta, okay, and this tells me dx becomes equal to sec square theta d theta. That's the first thing. Yes. Lower limit. Let's talk about the lower limit. Lower limit, which is x equals 0, tells me, okay, we have to deal with theta, right? We have to find the value of theta over here. So theta is tan inverse x. Theta is tan inverse x, which is tan inverse 0. This is 0. And upper limit, x equal to 1 implies theta will be tan inverse 1, which is pi by 4. This is what you get. And now let's take a look at I over here. I becomes equal to what? Integral from lower limit 0 to upper limit pi by 4. These are the values of theta, right? We are converting everything in terms of theta. Sine inverse 2 tan theta upon 1 plus tan square theta, which we have already thought. So this is 2 tan theta upon 1 plus tan square theta, which is sine 2 theta. Sine inverse sine 2 theta will be 2 theta over here. This is what we want to reach. And dx is sec square theta d theta. D theta. So now we can apply what? Can you see that you have theta and sec square theta? Yes. And where are we heading in this direction? In which direction are we heading? We are heading in the direction of applying integration by parts. Yes. So that 2 can be moved outside that integral first of all. Therefore, I is equal to 2 times integral from 0 to pi by 4 theta sec square theta d theta. And here I will first identify the first function and second function. uv, integral of uv dx is u times integral v dx minus du by dx integral v dx and its whole integral, right? So this is trigonometric function, this is algebraic. We'll take it inside the integral and this will be differentiated, right? That's what we'll be doing. So this is 2 times in the bracket you have u times integral v dx, theta times integral of sec square theta. Now integral of sec square theta is tan theta minus big integral of derivative of theta, derivative of this theta, which is 1, integral of sec square theta, which is tan theta d theta. This is what I get. Is that okay? Yes. This is what I'll be getting. And mind you, one more important thing. What's that? The limit 0 to pi by 4 will be applied over here on this. And here, since the integral is still remaining, we'll have to integrate that first inside. So this is 2 times, this is theta times tan theta minus integral of tan theta. What is integral of tan theta? Log mod sec theta, like this, from 0 to pi by 4. The limits will be from 0 to pi by 4. Now let's apply the limits. 2 remains as it is. In the bracket you have pi by 4 times tan pi by 4, which is 1, minus log sec pi by 4. Now sec pi by 4 is root 2. This is what you have. Minus 0, theta is 0, therefore this becomes 0, minus log sec 0. Sec 0 is 1, therefore log 1 will again be 0. This is what you get in the curly brackets. 2 times pi by 4 is pi by 2 minus 2 log root 2. Now if you observe carefully, this 2 will go in power of this and it becomes root 2 square, which is 2. So the final answer can be written as pi by 2 minus log 2. Is this correct? Yes. This is the final answer for this question, as you can see over here. Question number 4 says, evaluate integral from 0 to 2 of x under root x plus 2. And there's a hint given over there. Put x plus 2 equals t square, right? So we'll use that hint and see how does the question get solved. And I, as you can see, is integral from 0 to 2 x under root of x plus 2 dx. Okay, there's a dx missing over here. There should be a dx over here. Yes. 0 to 2 x under root of x plus 2. And we'll put x plus 2 is equal to t square. Right? Yes. This tells me dx will be equal to 2t dt. This is what you'll have. Is that okay? Yes. And lower limit. What about the lower limit? Lower limit says x equals 0. This tells me, okay, t will be under root of 2. 0 plus 2 is 2, t will be under root of 2. You could argue, okay, so t could be plus minus root 2. We'll take the positive one, t is equal to root 2. We have actually, you can see that actual substitution that we have made is replacing that x plus 2 by t. We have made this kind of a substitution over here, and therefore this. So upper limit tells me x equal 2, and that tells me, okay, x equals 2 will tell me t square equals 4, t will be 2. This is what you'll be getting, yes. And therefore I will be equal to what? I will be equal to integral from root 2 to 2, x is t square minus 2, under root of x plus 2 is t, dx is 2t dt, right? This is what you have. Is that okay? Yes. Once you are through with this, can you see that the 2 here will come out root 2 to 2 integral t square times t square will become t power 4 minus 2 t square. This is what you will get dt. This is what you will get. Okay, this 2 remains as it is. Integral of this is t power 5 upon 5 minus 2 t power 3 upon 3, and the limits are from root 2 to 2. Where does that take me? 2 remains as it is. We will substitute the limits. So this becomes 2 power 5, which is 32 upon 5 minus 2 into 2 power 3. 2 power 3 is 8 times 2 is 16 by 3. Okay, and subtract the other term. What's the other term? Substituting root 2. So root 2 power 5 is 2 power 5 by 2, which is 2 power 2 into 2 power 1 by 2. 4 root 2 is what I get upon 5 minus root 2 power 3. Root 2 power 3 will be 2 root 2 into 2 is 4 root 2 upon 3. This is what I'll be getting. Yes. Okay, so from here this 2 remains as it is. What will this simplify into? These terms contain root 2, so they'll be simplified together. These will be simplified together. We can take the LCM as 15, and 32 times 3 is 96, 16 times 5 is 80. 96 minus 80 is what I'll be getting. 96 minus 80 is 16. Minus, what do we have over here? 4 root 2 from the numerator will come out common. That's what you can observe. Yes, this is not 4th root of 2. This is 4 square root of 2. Yes. 4 square root of 2. 1 by 5 minus 1 by 3 will be 3 minus 5 upon 15. 3 minus 5 is minus 2 upon 15. That will become plus 2 upon 15 in the bracket over here. Okay, this overall simplifies to 32 upon 15 and plus 2 into 2 into 4 is 16 root 2 upon 15. Okay, this, or you can write the answer by taking something common from here. You can take out a 16 by 15 common. You can also take out a root 2 common, and what will remain is 16 root 2 by 15 times root 2 plus 1. This form or this form will be my final answer for this question, as you can see over here. Question number 5 says, evaluate the integral 0 to pi by 2 sin x upon 1 plus cos square x. How do we do that? So this cos x in the denominator can be substituted in terms of some other variable. Sin x dx will be the derivative of that cos x. Yes. So I, which is integral from 0 to pi by 2 sin x upon 1 plus cos square x dx. We'll use a substitution, a simple substitution. Cos x equals t, and this tells me that derivative minus sin x times dx will be equal to dt. The lower limit, can you identify the lower limit? The lower limit says x equals 0, and this will tell me that if x equal to 0, t is cos 0, t will be equal to cos 0, which is 1. Upper limit, x equals pi by 2. That tells me t will be cos pi by 2, which tells me t will be cos pi by 2, that is 0. Therefore, integral I becomes what? The limits will be from 0 to pi by 2. Instead of 0, the lower limit becomes 1. Instead of pi by 2, the upper limit becomes 0. Then you have sin x dx, which can be replaced with minus dt upon, you have 1 plus cos square x, which is 1 plus t square. Okay. Minus 1, as you can see, can come out from here. Dt upon 1 plus t square, the integral is direct tan inverse t. Substitute the limits from 1 to 0. Minus 1 remains as it is. In the bracket, you will have tan inverse 0, which is 0, minus tan inverse 1, which is pi by 4. So this is minus of minus pi by 4, which is pi by 4, and yes, that is my required answer for this question, as you can see over here. In the sixth question, the person says evaluate integral from 0 to 2 dx upon x plus 4 minus x square. How do we do that? So we have 1 upon quadratic form, right? So 1 upon quadratic can be evaluated by converting the denominator into a perfect square first of all. So x plus 4 minus x square, what I'll do is I'll first take this minus common to make the coefficient of x square positive. This becomes x square minus x minus 4. The next thing that we'll do is minus 1 remains as it is. The square of this, completing the square is very easy by taking half of this. This becomes x minus 1 by 2 square. Minus 4 is already there. There will be extra term minus 1 by 4 from here. This is what you'll get. So 4 times 4 is 16. 17 by 4. This will become 17 by 4. Multiply with the minus. This becomes 17 by 4 minus x minus 1 by 2 square. This is what you'll get. Is that okay? Yes, that looks okay. So therefore, I can write this integral I from 0 to 2 dx upon 17 by 4 minus x minus 1 by 2 square. Now this is of the form a square minus x square in the denominator. So one of the ideas is something which I have been using over and over again. One of the ideas is that you can simply use a square minus x square. Instead of x, we have a linear polynomial of x. That's something which can be used directly. Right? We can use direct formula and we'll be good to go. But then using substitution, what we can do is you can substitute this x minus 1 by 2 as t. Right? So put this substitution x minus 1 by 2 as t. That tells me okay, dx will be equal to dt, and lower limit says x equals 0. This tells me t will be minus 1 by 2. Upper limit tells me x equals 2. That tells me t will be 3 by 2. Using these, I can write I, the integral will be minus 1 by 2 to 3 by 2 dt upon 17 by 4 minus t square. This is what you'll get, right? Yes. And now I'll use the result. What's the result that I'm talking about? 1 upon a square minus x square integral with respect to x is 1 by 2a log modulus a plus x upon a minus x plus constant of integration. This is the formula that will be applied on this. Take a look at that formula again. Another idea could have been to use partial fractions on this, but on the basis of partial fractions, this formula has been derived. So we'll directly use this formula over here for 1 upon quadratic. This becomes okay 1 upon 2a. A is root 17 upon root of 17 upon 4. Now that becomes root 17 upon 2. So let me write root 17 upon 2 times log modulus a plus x, which is root 17 by 2 plus t upon root 17 by 2 minus t, like this. Integration limits will be minus 1 by 2 to 3 by 2. This is what we'll see. Is that okay? Yes, that looks okay up till now. What else? This becomes 1 upon root 17 log. What does this give me? Root 17 by 2 plus 3 by 2. Root 17 by 2 minus 3 by 2. If you see that 2 in the denominator will get cancelled, right? So this becomes root 17 plus 3 over root 17 minus 3. That's one of the things. Yes. And you can maybe take out this 1 by root 17 common, and I'll write this complete expression in bracket after subtracting the next one. So next one will be 1 by root 17, which is already there, log, with a minus you'll get log, substitute this, root 17 by 2 minus 1 by 2. Root 17 by 2 minus of minus becomes plus 1 by 2. So root 17 by 2 minus 1 by 2, root 17 by 2 plus 1 by 2. The 2's will get cancelled once again, and root 17 minus 1 upon root 17 plus 1 is what you'll see over here. Now we need to simplify this question a bit, this answer a bit further, although we have reached the final answer, but then simplification of these two logs is important. Let's do that. 1 by root 17, let it remain as it is. Log m minus log n can be merged together. Okay, this becomes log of m by n, root 17 plus 3 upon root 17 minus 3, divided by this expression. Okay, that means multiplied by the reciprocal, which is root 17 plus 1 upon root 17 minus 1. This is what we see. Yes, now can you simplify this a bit further? Yes, this becomes 1 by root 17 log, okay, multiply these together. This is root 17 plus 3, root 17 plus 1, root 17 times root 17 will be 70, yes, plus root 17 plus 3 root 17 is 4 root 17 and plus 4. So what does this become? This becomes 17 plus 3, not 4, 17 plus 3 is 20 plus 4 root 17. What about the denominator? In the denominator you have root 17, which is 17, minus root 17 minus 3 root 17 minus 4 root 17 and plus 3. So that again becomes 20 minus 4 root 17. Okay, in the brackets if you observe, what do we have? A factor of 4 comes out common from here, a factor of 4 comes out common from here. This becomes 5 plus root 17, this becomes 5 minus root 17. And we'll have to rationalize that as well, yes. So let's do it. 1 by root 17 as it is. Okay, log of, here you have 5 plus root 17, this is 5 minus root 17. Imagine this, factor of 4 gets cancelled, right? So you multiply and divide with 5 plus root 17. So this becomes 5 plus root 17 square in the numerator. Square, and in the denominator what do we have? 5 square minus root 17 square, which is 25 minus 17, that is 8. This is what you get. Yes, and the final answer will be, after squaring this, you will get 25 plus 17, which is 42 plus 10 root 17. Okay, and you can cancel a factor of 2, 21 plus 5 root 17 upon 4. I'll write the final answer. Is there space over here? Yes, there's pretty less space, but I'll write the final answer over here only. This tells me equals 1 upon root 17 log. This becomes 25 plus 17, which was 42, and plus 10 root 17, you cancel a factor of 2, 21 plus 5 root 17 upon 4. 4. That is my final answer for this question. As you can see, this complete solution, all these steps over here, starting from there to this particular point. Let me get a side for you to take a look at this answer, this complete solution, and that's all that you have in this question. Question number 7 says, evaluate minus 1 to 1 integral dx upon x square plus 2x plus 5. So once again, the process is simple. What do you have in the denominator is a quadratic. We'll have to convert that into a perfect square. I is integral from minus 1 to 1. Converting this into a perfect square is not difficult. This is x plus 1 whole square plus 4. Plus 4, which is 2 square, right? And for simplifying this, yes, we'll have to make a substitution, or we could move directly. That is, this is nothing but x square plus a square in the denominator can be simplified in terms of tan inverse, right? Instead of x, you have a linear polynomial of x. So that is still very simple. But then if you want to make a substitution, x plus 1 equals t. Put x plus 1 equals t, that tells me dx is equal to dt. The lower limit, x equals minus 1, tells me t will be minus 1 plus 1, which is 0. The upper limit, x equals 1, tells me t will be 1 plus 1, which is 2. And using these, I will become integral from lower limit 0 to upper limit 2 dx, which is dt upon x plus 1 square, which is t square, plus 2 square. Now this is 1 upon x square plus a square form. The integral is 1 upon a tan inverse x by a. 1 upon a tan inverse x by a. Limits from 0 to 2. And this further becomes what? This 1 by 2 remains as it is. This becomes tan inverse 2 by 2 minus tan inverse 0 by 2. Okay, this 1 by 2 is okay. Tan inverse 1, what is that? Pi by 4. Minus tan inverse 0, which is 0. So this becomes pi by 8, and that is my required answer for this question, as you can see over here. The 8th question says integral of 1 to 2, integral from 1 to 2 of 1 by x minus 1 upon 2x square e power 2x is supposed to be found. How do we do that? So e power 2x, if we have something of e power x form, along with that, if we can create fx plus f prime x, our life will be very easy. That integral is very simple, right? That's a very special integral. Here you have e power 2x. We'll have to simplify that by the help of substitution somehow. 1 to 2, this is 1 by x minus 1 by 2x square e power 2x dx. And the first substitution that I'll make over here is this. 2x equals t. That makes 2 dx equals dt. The lower limit says x equal to 1. That implies t will be 2 into 1, 2. Upper limit says x equal to, which implies t equals 2 into 2, 4. This is what you have. Is that okay? Yes. Once you are through with this, therefore the integral I will be from 2 to 4. What do I have over here? 1 by x. Now x is t by 2. If you can see that carefully, x is t by 2. So in the denominator you have t by 2 will be converted. 1 upon t by 2 will be this. Minus 1 upon 2 into t square upon 4. This is what you will get. E power 2x will become e power t, and dx will be dt upon 2. This is what you will see, right? Yes. So integral from 2 to 4, and if you observe, this 2 will cancel this 2. This is 1 by t minus this 4 becomes a 2. This will cancel with this 2. This becomes 1 by t square, and there is a e power t dt with this. Okay. If you observe, with e power t you have function and its derivative. Yes. If you have the function and its derivative along with e power t, therefore I will become equal to integral. Integral will be simply e power t into f, which is e power t into 1 by t. Put the limits from 2 to 4. What does that give me? E power 4 upon 4 minus e power 2 upon 2. Okay. So you can take out something common, yes. In the denominator I want to take out 4 common. In the numerator I have e square common. So what remains is e square minus 2, and yes, that is my required answer for this particular question over here, as you can see over here. That's the solution for this 8th question. In the 9th question we have the value of the integral, this integral from 1 by 3 to 1 x minus x power 3 whole power 1 by 3 divided by x power 4. Now what is that equal to, and how will we handle this? Let's take a look at this question. So in the numerator, can I take out something common from the numerator so that from that particular thing I can get the denominator as the derivative? Yes. So observe this I carefully and take a look at this particular step very carefully. Now we have seen questions quite similar to this, but not very similar. Basically, had this been a polynomial without this 1 power 3, this would have been very easy to solve, yes. Since this is x minus x power 3 power 1 by 3, this is not a polynomial, so it is pretty difficult to solve with any other means except for substitution. What kind of a substitution do we want to apply? Such that this particular quantity can be substituted as t and its derivative will be present with dx. If we observe x minus x power 3, 1 minus 3x squared, that's not present with dx, right? So we want to convert it into certain form so that the derivative is present with dx. Okay, so we can take out maybe this x common, but if you see this x power 1 by 3 will come out common. That will give me 4 minus 1 by 3 in the denominator, which is 11 by 3, and this will be x squared. Now the derivative of x squared is not x power 11 by 3 in the denominator. But I can take out this x power 3 common from here. So what will that give me? X power 3 power 1 by 3 will be x outside. X upon x power 3 is 1 by x square inside. Right? 1 by x square inside. X upon x power 4 will be x power 3 in the denominator. And since inside you have 1 upon x square, the derivative will be 1 upon x power 3. Yes, that's the important step. If you can observe that, the question becomes simple. So the important thing is 1 by 3 to 3. You take out x power 3 common, x power 3 power 1 by 3, which is x, comes out common. What remains is x upon x power 3, which is 1 upon x square minus 1 power 1 by 3 upon x power 4 dx. And this x gets cancelled, this becomes x power 3 in the denominator. Now this can be substituted as t and we can simplify the complete question. So put 1 by x square minus 1 as t. That tells me minus 2 upon x power 3 dx is equal to dt. This tells me this. Okay. What about the lower limit? Lower limit is x equals 1 by 3. What does that give me? T. T will be equal to reciprocal of x square. So x square will be 1 by 9. Reciprocal of that will be 9 minus 1, 8 is what I get. Upper limit is x equals 1. That tells me t will be equal to 1 by 1 square, which is 1 minus 1 is 0. This tells me t will be equal to 0. Okay. One very, very important thing to note from here is this important thing. Please note. This is not exactly clearly mentioned in the NCERT, but then while substituting, you'll have to take care of that. In case of definite integral, you are substituting 1 by x square minus 1 equal to t. This substitution should not be discontinuous. This is important, right? This should be a continuous and differentiable function for the substitution to work properly, right? Had the limits been from minus 1 by 3 to 1, we'll have to break the limits from minus 1 by 3 to 0 and then 0 to 1 for substitution directly, right? We'll have to do that. Okay, so keeping that idea in mind, you can see, okay, t goes from 8 to 0, therefore I becomes from the lower limit 8 to upper limit 0. You have 1 by x square minus 1, which is t power 1 by 3 times dx upon x power 3. dx upon x power 3 is dt upon minus 2. Okay, so this minus 1 by 2 will come out common. T power 1 by 3, the integral will be t power 4 by 3 upon 4 by 3, which becomes 3 by 4 over here, and you put the limits from 8 to 0. This is minus 3 by 8, which is okay. 0 power 4 by 3 is 0, minus 8 power 4 by 3. 2 power 3 power 4 by 3 will be 16. Yes, this is what you'll get. And what does this simplify into? Minus 48 upon 8, which is 6. That is the correct answer for this particular question over here. Oh, there are options given. Yes, the correct answer is this option A, as you can see over here with the help of these calculations. Important step over here. And before that, obviously, some manipulation is required at this stage. This is very important. Is that all? Yes. In this question, it is solved. In the 10th question, we have, if fx equals 0 to x t sine t dt, then f prime x is equal to what? Oh, we just have to find the derivative of this. Yes. So if you are aware of something called Newton-Leibniz theorem, then you can write that derivative directly as, okay, fx is equal to integral from 0 to x t sine t dt, and f prime x will be simply equal to, you substitute this, x sine x. Is that all? Yes, actually that's all. By the Newton-Leibniz, you'll be able to reach this stage. Oh, yes, yes. But then, if you don't know Newton-Leibniz, then you will have to solve it using some other means. Yes. And what is that other mean? Nothing much. We'll have to find that fx first after integration, and then we'll differentiate it back. Right. So let's begin with at fx. 0 to x t sine t dt, and this can be solved with the help of integration by parts. This will be the first function, this here will be the second function. Yes? Yes. First function t times integral of sine t, which is minus cos t, minus derivative of t, which is 1, integral of sine t, which is minus cos t dt. This is what you will get. And yes, the limits of integration from 0 to x will be applied. But before that, let's integrate this as well. This is minus t cos t, minus of minus becomes plus, integral of cos t, what is that? Sin t. Now apply the limits from 0 to x. Therefore, fx is equal to what? Substitute the limits. This becomes minus x cos x plus sin x. And what about 0? 0 and 0, both the terms become 0. So, this is f of x. And now you can find derivative with the help of your general ideas. What are those? You can apply product rule on this. So, minus x, the derivative of cos x is minus sin x. Derivative of x is 1, so this becomes minus cos x. Derivative of sin x is cos x. Okay. This becomes x sin x. And obviously this gets cancelled. So, f prime x is nothing but x sin x. F prime x is nothing but x sin x, yes. So, that is the derivative, the correct answer being this option B over here. That is a complete solution, as you can see over here. First we have found fx, then we have differentiated it to get f prime x, yes. That is the way to go about this particular question. So, that is all in this question and as well as this exercise. Till the next session, all the best.